Imagine two users in the same physical room, trying to send a secure message from one laptop to another. It sounds like the simplest problem in networking. Typically, we solve this in one of two ways. On the left, we use a centralized messaging model. Node A sends data out to the internet, up to a cloud server, which then routes it all the way back down to Node B. On the right, we have a direct peer-to-peer model, where a single line connects the two nodes locally. That centralized model guarantees the message will probably arrive, but it forces local data through external infrastructure. This introduces unnecessary latency and creates privacy vulnerabilities, as all communication must be processed by a third-party server. The direct peer-to-peer model keeps the data entirely local, but getting it to work requires non-technical users to manually look up and share internal IP addresses. Even if they manage that, the architecture is brittle. A localized firewall rule or a momentary connection drop kills the session entirely. Network engineers are generally forced into a strict trade-off. They have to sacrifice local routing efficiency and strict privacy just to gain the reliability of a centralized server. EchoLAN is a Java-based, dual-mode peer-to-peer command line application built to eliminate that exact compromise. The core mandate of this project is to decouple the mechanics of security and routing from user action, ensuring connectivity remains active even as the network state shifts. It achieves this through three specific architectural pillars: human-readable addressing, zero-configuration encryption, and adaptive routing logic. The independent development and integration of these subsystems creates a specific, reproducible framework for local-first communication. The first layer of this architecture tackles the problem of node discovery. How did two clients find each other on a local network without a central directory telling them where to look? EchoLAN intercepts the numeric array of a local IPv4 address, feeding it into a custom conversion algorithm. This parses numbers against a deterministic BIP39 word list, translating a standard IP like 192.168.1.15 into a three-word magic address like forest, silver, anchor. Standard local networking tools require users to open command prompts, search for their specific IPv4 configuration, and accurately read those digits back. By abstracting the base network layer into a memorable, human-readable identifier, EchoLAN removes the technical friction of manual IP exchange and improves local discoverability. Once the nodes know how to find each other, the secondary requirement is securing the data payload across the local network without relying on user-configured certificates. The system mandates end-to-end encryption, and it forces that process to operate strictly on the client side. Upon client boot, the security workflow begins automatically. A local RSA key pair generates independently on each machine. When a user connects via magic address, an automated handshake triggers. Crucially, only public keys cross the void. Private keys remain isolated locally. Because this exchange happens instantly at connection, all subsequent payload data is encrypted locally before it ever interfaces with the TCP connection layer. By embedding this RSA exchange directly into the connection protocol, robust cryptographic security isn't an optional setting a user might forget to turn on. It becomes a baseline. We still have to address the primary threat to direct peer-to-peer systems: edge network brittleness and localized disruptions. This is where EchoLAN introduces its core routing logic, a background process known as the connection manager daemon. The daemon operates with a primary directive. It always prioritizes localized routing via LAN direct mode to ensure latency stays as close to zero as possible, but it constantly monitors the health of that local connection. If direct connectivity fails, perhaps due to a firewall rule or subnet mismatch, the path is severed. The connection manager executes an instantaneous pivot to hybrid cloud mode, bypassing the restriction. This logic supports multiple connectivity matrices, switching between LAN to LAN, LAN to cloud, or entirely cloud to cloud routing, depending on what the network environment allows. Because this transition is handled entirely beneath the application layer, the underlying RSA-secured chat session continues intact. The user never sees a dropped connection. This adaptive logic solves the core availability problem of peer-to-peer networking. It grants independent local nodes the continuous resilience normally reserved for centralized servers. The final structural challenge is application state management. If there is no central server, retaining a history of the chat session requires a local solution. EchoLAN integrates a localized SQLite database. When a message is decrypted and displayed on screen, a duplicate copy is written directly to the client machine's physical disk. When a user reconnects to a previously authenticated magic address, the system triggers a local query. It automatically retrieves that local data to restore the exact conversation context. Decentralized state management guarantees that the user maintains complete data sovereignty over their communication history, while ensuring operational continuity across sessions. Taking a step back, we can see how these four independent phases operate as a singular, cohesive software architecture. The data lifecycle follows a path from Client A through magic address resolution into the connection manager, executes the RSA key exchange, facilitates the secure chat session, and terminates in local SQLite storage. The project has transitioned from a conceptual design to a technology readiness level of 5 and 6. The working prototype currently executes multi-threaded communication loops and natively supports operational image sharing alongside text data. This architecture has immediate practical applications in educational intranets, secure corporate environments, and disaster recovery scenarios where external networks are unavailable. The fusion of these components establishes a specific, integrated workflow for hybrid peer-to-peer software. This original implementation, combining secure communication, adaptive networking, and user-friendly addressing, forms the basis for our software copyright registration.